Okay, good morning, 6 years. I just want to run through corrections from yesterday. Good bit of work in these problems. Question 1, question 2, question 5, question 6 I'd asked you to do. So I'm going to flip between the textbook, I'm going to flip between GeoGebra, and I'm going to flip between my camera roll because I've taken pictures of my written solutions. So there was a lot in this, and if you didn't get through all of it, I would be completely understandable or completely understanding of that, but you can see, and I'll show you in the video, the bits that we've got done. So hopefully you will have a better understanding of this before we move on to the next ones today, which are a little bit different, the maximum and minimum problems. So question 1 is our first one here. We're given the graph, or we're given the function, or we're given a graph as well. It tells us that x1 and x2 are x values of the turning points of the curve. So we can see that the curve f of x turns at g and at h. So it turns down and then it turns back up. Okay, so we've got everything we need there to answer the questions. First one, it says to solve the quadratic equation f prime of x is equal to 0. So first thing to do, I find my f prime of x. I'll go back here, question 1. I find my f prime of x and I put it equal to 0. So the function at the start is up there, x cubed minus 3x plus 1. I find the first derivative of that to get 3x squared minus 3. I put that equal to 0 and then I solve for x. Now I end up with x squared is equal to 1, as you can see here. Now when x squared is equal to 1, I have to get the square root of 1, or I have to think about what number do I square to get 1, okay? But as I am sure you can see there, okay, x could be plus 1 or minus 1 in this case. And as I said, I've got your 3 dots there in the triangle pointing downwards. That means because in our mathematical language, and because minus 1 squared is equal to 1 and 1 squared is equal to 1. So x could be either of those values, okay, 1 and minus 1. Now that makes sense to us as well, because if I go back to the question, I've got two x values. I've got x1 and I've got x2. So I would expect to have two x results. Sorry, I'll just go back to where we were. And I have 1 and minus 1. Okay? So, part 2 then says, find the coordinates. Explain why the solutions to fx is equal to 0 are x1 and x2. Explain why the solutions are x1 and x2. Now it's telling you in part 2 that you should have two answers. So if you didn't get two answers, you know you've made a mistake. Alright, so part 2, as I've written here, f prime of 0 equals f prime of x, the f prime of x is equal to 0. That shows that the slope of the curve is equal to 0, because when I put that, remember the first derivative is equivalent to the slope. So when I put that equal to 0, it's telling me that the slope of the curve is equal to 0, or telling me that the turning points are there, because the slope of the curve is 0 at those turning points. If you look back at the diagram, we can see that at the point G and at the point H, that there is a straight line of a tangent. If I was to draw a tangent there, and let's do it very quickly, if I was to draw a tangent, it would be, let's see if this works for me now. No, not working at the minute. So if I was to draw a tangent at G and a tangent at H, they would be parallel to the x-axis, if you can understand what I mean. So they'd be straight horizontal lines across the diagram. So they would have a slope of 0, the same as the x-axis has a slope of 0. So that's what we're saying, okay? In that problem, we have the slope of 0. So the slope of the curve is 0 at those 2 points at G and at H. Now, G is the local maximum. G is the local maximum because that's the upward part. So that's where the function comes upwards and then it turns back down at that maximum. So it's reached its max at point G and it's reached its minimum at point H. Now it's local max and local min. You can see that the function continues on downwards on the left hand side and upwards on the right hand side when we look back at it in a few minutes, and I have it done on GeoGebra to show you as well. So as you can see here, it says x1 and x2 represent the x values at the local max and min, where the slope of the curve is equal to 0. Now, again, I've gone through a full explanation there to make sure you're clear on what's happening. I wouldn't expect you to be writing as much as that, but it's just a full explanation for you guys. Just to have a think about the local max and min, if I go to GeoGebra and I show you, that's what the function looks like. You can see, here's one I prepared earlier. Okay, the function, the green function, is the one from question 1. And you can see what it looks like. Okay, and if we pop in a point there and a point there, they actually represent the points G and H in the diagram that's given to us in the question. So A, as we're looking at it now, is the local max, and B, as we're looking at it now, is the local min. Okay, so that's the way that works. Let's get rid of those and we'll go back. So the next bit then, that's part 1 and part 2 done. Part 3, it says find the coordinates of G and H. Now I have the x values of G and H already. The x value at x1 is -1, of course, because that's the negative side of the x-axis. And the x2 value is 1, +1. So all I got to do is use those. I'm going to use those x values of -1 and 1. As you can see, x1 is -1 and x2 is +1. So I fill them into the formula. Fill them into the original function, x cubed at the very top there, x cubed minus 3x plus 1. And I fill them in and I get my value for y. And then that gives me my G point and my H point, my coordinates of each. So I fill in -1, it gives me 3. I fill in +1, it gives me -1 as an answer. And then I have the coordinates of G and H. And that makes sense, okay? Because if I go back here and I fill them in there, G in the question, okay, would be -1, 3. And H will be 1 -1. Forget about that C for now. Okay, so that's it. That will be the point. -1, 3, -1, 3, and this would be 1 -1, and they're the 2 points that I worked out. All right, so that's that. That's all those done. So that's question 1 complete. I'm going to go back and look at the rest in a second. So, question 2 is the next part. Find the coordinates of the turning point. So this is very similar to what we've just done. Okay, part 3 is where we found the coordinates. Part 3 of question 1 is where we found the coordinates of the turning points G and H. So we're going to do the same thing for question 2. We've got a new function. It also says determine the nature of the turning point. So what that means is I want to be able to distinguish which one is the local maximum and which one is the local minimum. Okay, so we'll go back to my corrections. Question 2. All right, now look, I've got 4 steps to show you how to work out or to find how to find the turning points. So number 1, I find my derivative. Number 2, I put that equal to 0. Number 3, I solve that for x. And then I use the x value or the x values to find the y values. So very similar to what we did in question 1. So I've got my function, y is equal to x squared plus 2x minus 8. I get my derivative, nice and simple, 2x plus 2. I put that equal to 0, and then I solve for x. So that's step 1, step 2, step 3 done, nice and quickly, okay? Then step 4, I use my x value. You can see I've got x is equal to -1, and I substitute that in for my x value. I put that in to my original function. So that's the original function, and I'm popping it in to there. And I solve, and I get my turning point is -1, -9. Now, it also asks for the nature of the turning point. So, if this is where we get into it here. So I'm gonna go back to GeoGebra and show you here. Okay, so the function, get rid of that one, and this is the function for question 2. All right, that's what it looks like. You can see it there in top left, the red dot, x squared plus 2x minus 8. That was the function that was given to us in the question. So the point -1, -9 is the one that I worked out was the turning point algebraically. If I pop that point on, that's the point D there, okay, essentially. That is -1, -9, if you look at it there. So, two things. If you're not able to use GeoGebra like you would do in an exam, there's a different way of figuring this out. We can see, okay, in what's given to us there, g of x, or the red one that represents question 2, x squared plus 2x minus 8. You know that that's a function, you know it's a quadratic function, and you can see that the x squared is positive in this instance. So the x squared is positive, and that tells me, as you guys know, when I have a positive x squared value, I know I'm getting a U shape or a smile, if you remember, okay? So that gives me a positive shape, yeah? We know. So we think positive, we smile. So we get a smile shape for the positive x squared value. So you can see that in this function, I have that U shape, and the turning point that I've worked out has to be at the bottom of that curve. There's no other turning point in this curve. So, as I've said in the written answer here, if I go back again, the turning point, as you've said there, is -1, -9. Now, as I said, the function is positive x squared value, so I have that U shape or that positive small shape. And -1, -9 is the turning point, and it has to be a local minimum. It has to be a minimum because it's at the bottom of the curve. So the minimum means that it's the downward point where the function is coming down and then back up again. So this is our local min. And that's it. Done and dusted.